To my YouTube channel today. Remember, I promised to teach you the electric field pattern when I taught you electric field. Okay, now the electric field pattern is also a subtopic for your electric field. That is why you have to pay attention to this. Okay, if you are preparing for JAM and post UTME, please make sure you follow up with this class. If you have not watched the previous video on electric field, please go and do that so that you understand this properly. Now let's do this carefully. Now, electric field pattern, the fundamental law of static electricity. Remember, electric field has to do with the force of attraction or the force of repulsion between two charges. And these charges could be like poles or unlike poles. And remember that the law of static electricity states that like poles do what now? Repel. That means positive will repel positive. Negative repels what? Negative. Is that clear? Good. Again, but positive will attract waiting a negative. Sorry, negative will attract what now? Positive. Okay? So, like poles repel, unlike poles do waiting they attract. Now, what are we going to do? First of all, in this video lesson, we are going to talk about the electric lines of force. Good. What does electric line of force talks about? Let's begin with electric lines of force. What does electric lines of force mean? Electric lines of force is a line that indicates the direction of the electric field. If we talk about lines of force, it's a line that indicates the direction of a field. So for electric lines of force, it is a line that indicates the direction of the electric waiting field. Now, if this guy indicates, it means that without the electric lines of force, you cannot trace the field pattern. Is that clear? Yes. Now, how does these lines of force look like? Are they physical lines? No, they are imaginary lines. So we can say that electric lines of force are imaginary lines that indicate the direction of the word, the electric field pattern. And this guy, electric lines of force, has properties which we call properties of electric lines of force. Lines of force. I have told my students countless times that physics is not just all about calculation. There are sometimes you'll be giving questions like which of these does not describe the electric lines of force. So it is important and pertinent that you understand this properly. Okay, what are the properties of the electric lines of force? Number one, they are imaginary lines. They are what? Imaginary waiting lines. Are you there? Yes, they are imaginary lines. Okay. Number two, they originate from the what? The positive charge and ends in the waiting in the negative charge. Please take note of that. Okay. Number three, they repair each other sideways. They repair each other sideways. Take note of that. They repair each other sideways. We can say number four, they never intersect. Why? They are parallel. So we can say that they are waiting parallel. And what? And never intersect. Please take note that they are parallel and they will never intersect. Then that's 1, 2, 3, 4. Okay. Number 5. It indicates the direction of the electric field. It indicates the what? The direction of the waiting electric field. Take note of that. It helps you to know the direction of your word electric field. Are we together? It is also called the electric field strength or the electric field intensity. So these are the properties of the electric lines of forces. Take note of that. Now, what is this field pattern we are talking about? Take note of this. That field patterns. These field patterns are like this. Number one, we have isolated positive charge. That means a positive charge that stands on its own. How does the field pattern look like? Good. Isolated waiting positive charge. For an isolated positive charge, the field pattern, this is the positive charge. Note that. This is what usually happens. Now, positive charges always give out. So the direction will be like this. Make sure you understand this direction properly. Please take note of that. The direction will be like it's giving out. Don't reverse it in the other way around. Number 2, isolated what? Negative charges. If you don't understand, maybe you have been reading this in your text before and you don't understand it, you can understand it here. Now, the negative charges, remember, negative charges attract, they receive. Remember in chemistry, the electropositive metal always give to the electronegative metal. You can use that to remember it. So if we have the same field pattern here like this, yeah, like this, this time it will be receiving. This for negative charges. So negative charges always what? Receive. Please take note that they always waiting and receive. Isolated negative charges. Number 3, please take note of this. Number 3. Between two similar positive charges. Two similar positive weighting charges. That's number 3. How will two similar positive charges look like? Yeah. How will two similar positive charges look like? For similar positive charges, we have this. For similar positive charges, we have, if I have a positive charge here, and I have another positive charge here, this is what you see. Now watch this. Remember that positive charge always gives. See, it always gives out. So it might give out from here. Let me adjust this a little. Now, if I have a positive charge here, and I have a positive charge here, it can give out this way. Let's do this carefully. So all of these are giving out. Please think of that. This will also give out. Yeah, it will give out. Then if it's giving this way, it will repel backward like this. It will be repelled backward because positive charges can never attract, they will repel. That's why man and man cannot marry each other. Likewise, a woman and a woman cannot marry each other because they will do what now? They will repel. Are you seeing it now? Go. So between two similar positive charges. That's number 3. Number 4, between two similar negative charges. Between what? Two similar negative charges. Now, if I have a negative charge here, and then don't forget that negative charge always attract. So even if I have the same field pattern that way, the way this one is, if I have the same field pattern, okay, it will be receiving. Please please, this must be noted. It must be noted. They will both be what now? Receiving. Then even if the field patterns go this way, it will repel, but on direction that it will be receiving. It will be receiving. It will be receiving. It will be coming in. Take note of that. It will be coming in, but it will repel. It will be coming in, but it will repel. Do you see it now? So positive is always going now, but negative is always what? Receiving. Then number 5. Number 5 is also very easy. Okay, between two unlike charges. You know what this means? To say that we are referring to two unlike charges, it means positive and negative. They are not the same and they are going to attract. And if they will attract, how are they going to attract? See, this is positive. This is what now? Negative. Don't forget, positive gives out, negative receive. So if I draw a line here, if I draw one here, and I draw one here, the positive will always give to the word negative. The negative will receive to itself. So if I draw a field pattern here, another one here, the same thing will happen. Even if I have one here, the negative will receive. If I have one here, the positive will give out. If I have something like this, the positive will always what? Give out. If I have something like this, the negative will always wait in a repel. Wow. So negative is always receiving. Positive is always what? Giving out. In case you are given a diagram, this diagram can appear in your exam. We all know that like poles repel, but you do not know the direction of the field pattern, and that's the reason for this video lesson, to know the direction of the field pattern so you will be able to answer your question correctly. Lastly, that's number 6. Number six, two opposites, okay, two unlike parallel charge bodies. Two unlike parallel charge bodies, okay? If I have a parallel conductor, two parallel conductor, one here, one here. If this is a positive parallel conductor and this is a negative parallel conductor, what do you do? Very simple. Remember that the field pattern will be parallel here. Please take note. The electric lines of force will be parallel here. See, as you can see it now. This is what will happen. But at the edges, it's going to bulge out like this and bulge out like this. Same with this place, to bulge out this way and bulge out this way. Good. So this is the field pattern for two unlike parallel charge bodies, okay? Or two conductor, positive charge conductor, negative charge conductor. Wow. So if you have my previous video lesson where I taught calculations involving electric field, electric force and the rest, and you have this, it means that everything about electric field has been covered for you. If today is your first time for coming across my YouTube channel, please do well to subscribe to this channel, okay? Help me to share this video with your friend. Please do not forget to like and also comment. Put your comment. If you have a question on this, put your comments send me a message on the comment section and I'll reply. Thank you very much. I'll see you in my next video.